In this segment, we're going to talk again about integers, and we're going to talk about subtracting integers. I'm going to do it in two sections. The first section is going to be using the integer chips, and the second section is going to be using the concept of the opposite of. So our first question is going to be 4 subtract 2, or 4 take away 2. And to clarify it with the integers, I'm going to show us with an expanded version of that, so we can see that it's not just any 4, it's a positive 4, and we're going to take away 2. Take away what kind of a 2? We're going to take away a positive 2. So here's one way of expanding this question, 4 subtract 2, and so now we have a positive 4, and then we're supposed to take away 2 positives. So we start off with 4 positives, 1, 2, 3, 4, and then from that we're supposed to take away 2 positives. So I can do that. I can take away 2 positives, and my answer is whatever I have left over, positive 2. I'm going to leave that question up there so I can come back in the second half and make sure I'm talking with the same kinds of questions. So I'm going to leave that there for now, and we'll move on to our next question. So up here on the right is our question. We start with a negative 3, and from that we're supposed to take away a negative 2. So we start off with 3 negatives, and from that we're supposed to take away 2 negatives. So I take away 2 negatives, and my answer is going to be 1 negative, or negative 1. Our next question starts with positive 4, and from that we're supposed to take away a negative 3. It doesn't really look all that much different than the other questions, but this one's somewhat problematic. It asks me to start off with 4 positives, so here's my 4 positives, 1, 2, 3, 4, and from that I'm supposed to take away, in my subtraction sign, take away, or minus, I'm supposed to take away 3 negatives, but I don't have any negatives to take away, so I have a problem. So how do we solve our problem? We solve our problem with our zero pair. My zero pair is going to allow me to place some things in there without changing anything. If I add a zero pair, we've talked about this before, if I add a zero pair, nothing changes to my teeter-totter or to my question. So if I added a zero pair to this question, I would still have 4 positives and a nothing. So it hasn't changed it, it's still 4 positives. But now I have a negative that I can do something with. If I needed to add another zero pair, I could do that. I could add an infinite number of zero pairs, and it would still end up actually only meaning 4. 1, 2, 3, 4 positives, and all of these all are zeros. So 4 plus 0, however many zeros I have, doesn't make any difference. So what I need in this question is I need to have 3 zero pairs, because I want to, it says I start with 4 positives, there's my 4 positives, and take away 3 negatives. And now I have some negatives that I can take away. So now it says have my 4, and I want to take away 3 negatives, and there I have 3 negatives. So I can take 1 negative away, I can take 2 negatives away, and I can take 3 negatives away. What's left when I take my 3 negatives away? Well, I have 7 positives. So my answer to positive 4, take away negative 3, is positive 7. Once students get the hang of this, it goes quite well, but it's going to take a few practice pieces, a few examples of adding the zero pairs to be able to have what I need to take away. This next question is similar to the last question in that it does not have enough of what I need to take away. So let's do this question. I start off with negative 4. There's my 4 negatives. And then it asks me to take away 5 negatives. So start with negative 4, take away 5 negatives. But I don't have 5 negatives to take away. If I pulled them away, I could pull them away, but then I'd be missing. I couldn't pull 5 things away. So what I need to do is I need to take one of my zero pairs and put that in there. So now that doesn't change anything. Anytime we add a zero pair, I still have my 4 negatives and a 0, so that doesn't change anything. But now, when it's asking me, can I take away 5 negatives? I can do that now. I can take away 1, 2, 3, 4, 5 negatives. Wait 1 second. And the last one, I can take my last negative away, and it's going to leave me with 1 positive. So I started with 4, I added an extra 0 pair, so now I can take away my 5 negatives, and it leaves me with an answer of 1 positive, or positive 1. In this question, we start off with 4 negatives, and we're supposed to take away 6 positives. So here's my 4 negatives, 1, 2, 3, 4, and I'm supposed to take away, subtract, 6 positives. But if I don't have any positives, how can I take them away? So our 0 pair comes to the rescue again. So I add in some 0 pairs. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6 0 pairs. So with all these extras that I've put on there, it still equals -4. And we want to make sure that students understand that. I've got my 4 negatives, and these are all just zeros. They don't change my number line, my teeter-totter, nothing changes. So I'm still sitting here right now with -4. And now it asks me to take away 6 positives. Well, now I have some positives that I can take away. So I go ahead and I take away my 6 positives. 1, 2, 3, 4, 5, 6. And so I've taken away my 6 positives, and what do I end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they're all negatives. So -4 subtract +6 is -10. So let's take a second here. These are the questions we've worked at, just to take a look at some patterns. I've asked in this question here, we had some positives and we want to take away some positives. So they're the same kinds of things. In this question we had some negatives and we want to take away some negatives. So that was the same kind of thing. In this question we had some negatives and we wanted to take away some negatives. And so that worked. So it doesn't matter if we're taking away the same kinds of things, this technique still works. On the first 2 examples, we were taking away less than what we started with, and in this question, we were taking away more than what we started with. It didn't make any difference. This chip strategy of working with the 0 pairs worked for all of them. In these examples, I started with some positives, but I was asked to take away some negatives, and this one I started with some negatives, and I was asked to take away some positives, and the chip technique worked for those as well. The first one here, I'm taking away less than what I started with, and this one I'm taking away more than what I started with. It doesn't matter. The chip strategy works for all these different kinds of questions. For the remainder of this segment, I'm going to be looking at the subtraction as meaning the opposite of. So we've done the chips, and that technique works well, and it works well for many, many students. What I want to show you is another way of looking at it, and this way probably ties in with multiplication and division a little easier, but I want to just point it out to you. So if what we've done up until now is good, we can stop here. So this first question, let's take a look at this first question. Right now it says I want to start with a 4, and then I'm supposed to take away a +2. How I could look at this question is I could say that I want to start with +4, and then instead of saying subtract, I want to say that that subtraction sign means the opposite of. And right now it says here that I'm supposed to add 2. So this question could say, instead of +4 subtract +2, it could say +4 and then do the opposite of adding 2. So this blue subtraction sign is the blue words the opposite of. So what's the opposite of adding 2? The opposite of adding 2 is subtracting 2. So 4 subtract 2 would give me the answer of +2. The next question right now says start with -3, and then I'm supposed to take away 2 negatives. But I could also say that I start with a -3. There it is. And then the subtraction sign says take away, but it could also mean the opposite of. And instead of the opposite of negative 2, we want to do this instead. So instead of saying negative 3 take away negative 2, we're going to go negative 3. What's the opposite of subtract 2? The opposite of subtract 2 is add 2. And negative 3 plus 2 gives me negative 1. And so we get the same answer either way. Our next question is positive 4 subtract negative 3, but we're going to reword that. So it comes out as positive 4, the opposite of subtract 3. The opposite of subtracting 3 is adding 3, so this question could be written as positive 4 plus 3, which would give us positive 7, which is the same answer. So in each of these examples, we see the opposite of idea being shown. So we started with positive 4. We're going to do the opposite of adding 2, or positive 2. So now we could rewrite that question as positive 4, changing the opposite of subtraction to adding. And instead of saying a positive 2, we now have a negative 2. Negative 3, subtract the opposite of negative 2. So the opposite of subtraction becomes addition, and the opposite of negative 2 becomes positive 2. So we could rewrite this subtraction question as an addition question. Positive 4, subtract negative 3. We can change that positive 4, do the opposite of subtract 3. So we can change the opposite of a subtraction becomes an addition, and the opposite of a negative 3 becomes a positive 3. So we get the answer of 7. So you'll often hear this statement here, that you can change any subtraction of something to an adding of that opposite thing. Some students think that it's always going to be changing to a negative number, but it's not. It's going to be the opposite of it. And so this is a rule that we sometimes get to, especially in high school. And as students work with the chips, they may find this rule out themselves. I wouldn't show them this rule until they can come up with that. When they start coming up with the rule themselves, or coming up with the idea of a rule, then maybe we could show this pattern and show them what that rule might look like. But eventually what inevitably happens is the rule that they come up with for adding and subtracting is changed when they see multiplying and dividing, and then they mix them all up. So we're going to be talking about multiplying and dividing next, but for now I think just working with the chips makes subtracting using the zero pair the easiest way to show subtraction of integers.